Substituting a quarter in for y. We get 2 1/4. And we sub 0 and 1 in. Get a point at 3 3. Subbing in 1 4. 2 2/3. And 6. Plot our points, right? 3 1/3, so 3 and a little bit, 2 and a little bit, and then 3 3, and then 2 2/3, and 6. Asymptote at +2. So again, our line goes here. And then we come in, sharp turn. And that's our graph. So we're going to finish off here with 4 examples. I think once we go through these 4, then things should be a little bit clearer. So I'll go through them relatively quickly, because all of them do have the same sort of steps involved. The first step is, of course, to determine the base so that you can use the parent function. And the first one is 4. So I'm looking at hx equals 4 to the exponent x. I know that I'm using -1, 0, and 1. So that gives me a quarter, 1, and 4. Come up with the expression, k value of -1/3, which means I multiply my x's by 3, subtract 2 from x. There's no a value in front, and there's no c value at the end. So really nothing's happening to y in this case. It's just going to be -3x minus 2 and then y. Sub those in. We get 1 1/4, right? -2 1 and -5 4. Plot our points. 1 1/4, -2 +1, -5 +4. Asymptote, again, because there's no number at the end, no c value, I still have to have an asymptote, which is at 0. So I'll kind of come in this direction, hit those 3 points, and then make sure I don't touch the x-axis. And make sure you put an arrow at each end, of course, because it does continue on indefinitely in both directions. Now, if you want, perhaps at this point you could pause the video, go ahead and work on the other 3 yourself, and then come back and kind of see how you did, if you understand this or not. Moving on to the second one, again, base is 3, because I have the exponent up here to the right. So with a base of 3, hx equals 3 to the exponent x. So -1 1/3, 0 1, 1 3. Deal with the x's first, 2 minus 1. So I'm going to have 1/2 times x plus 1. The y's, -2 and 3, -2y plus 3. Sub those values in. My new points are going to be at 1/2, 2 1/3, 1 1, and 1/2, 1 1/2, -3. So we sub our values in, 1/2, 2 1/3, 1 1, 1 1/2, -3. So really, really close together. Asymptote at +3. So graph comes along here, hits those points, and then essentially goes straight down. For this one, base is 1/2. So fx equals 1/2 to the exponent x. So again, -1, 0, and 1. 1/2 the exponent -1, 2, 1, 1/2. I have 2x and y minus 3. No a value, no d value. So after I sub in, -2, -1, 0, -2, 2, -2.5. Plot them. -2, -1, 0, -2, 2, -2.5. Asymptote at -3. So I'm gonna have a gradual graph kind of coming in, hitting those, and then coming out this way. Going down because, of course, with the base being a fraction, we all know we go down to the right? Decreasing graph. And for the last one, my base is 3. So gx equals 3 to the exponent x. -1, 0, 1. 1/3, 1, 3. My x's, -1/2, x minus 4, y minus 5. Because there's no a value in front of the base. My points are -3.5, -4 2/3, -4, -4, and -4.5, -2. Asymptote at -5. So -3.5, -4 2/3, so almost -5. -4, -4, really close together. And then -4.5, -2. It's kind of up here. Asymptote at -5. And again, come down, connect those 3 points, sharp turn, creating almost like an L. And there's our graph. Now at the bottom, I have 2 or 3 homework questions here, sorry. We're not gonna do those homework questions because I find they don't really help, or they don't have a lot of practice with graphs. So what we're doing in place of that is there is going to be an assignment worksheet that I have attached to D2L, which are similar to, which is the same as this. So I just have a selection of graphs that I would like you to do. Just fill in exactly the way I did here, and then take that and then upload it into the assignments folder on D2L. So you can take a picture of it, or you can scan it, and then just upload it back to me so I can see how your graphing is going. If you don't have a printer and you can't print this out, then just go through the expressions, create your new points, and then just do a rough sketch on a lined sheet of paper and approximately plot the points. They don't have to be super accurate, but just give me some sort of visual when you graph it, making sure that you highlight what the asymptote is, and then you're not crossing the asymptote. Okay, so something similar to this. Lined paper is fine if you can't print this out, and then just kind of scan it or take a picture, then upload it, send it back to me through the assignments in D2L. All right, thank you very much.